Hello and welcome. My name is Alan Wylęgała and today I am going to review Pentacam AXL Wave Plus. This is the most advanced version of Pentacam and it not only offers the very well-known maps from other Pentacam, but this time it has also wave aberrometry and also AXL, axial length measurement included. So please watch with me a review of Pentacam AXL Wave. But before we do it, let me tell you a few words about the Pentacam cameras. So we have different types, from the simplest Pentacam to the most complex one, which is the AXL Wave, which I am going to talk about. This simplest one, it has all the maps and analysis available except for the IOL calculator and the phakic IOL. And the maximum resolution is 25,000 measure points, and then we have the HR Pentacam. This is the high resolution. In addition, it has the phakic IOLs and the IOL calculator, and the resolution is much higher because it's 5 times higher. Another one, that's the Pentacam AXL. This one, as the name implies, has all the functions of the HR with also axial length measurement, so you don't have to put manually the axial length into the IOL calculator, but this is done automatically in this one. And then you have the Pentacam AXL Wave, which is the most advanced one. Here we have all the functions of the previous ones, but you also have the retroillumination, the refraction, as well as the wavefront aberrometry. The new Pentacam in appearance is almost no different from the previous models. There is the characteristic dish with a grey disc that rotates. We have a frame. We also have a computer on this side, and we have the inscription of the AXL Wave in case of this most advanced model. The whole camera is directed and controlled with the joystick. I'll show you how it looks in practice, and you can also lock the column for transpose. In the case of models that have the ability to measure the length of the eye, we also have the artificial eye for calibration. It is conveniently placed next to the frame, so there is no possibility of losing or putting it on. We change the height of the chin rest with such screw, and then the measurement of the camera itself is very nice. It looks a bit like at a disco because it has a red light inside and there is a blue bar, and it all is spinning on top of that. This is what the database looks like. We can search for a patient, we can add a patient if we already have the patient on the database. We click on the Pentacam, we go to the test results, take the picture, and this is what it looks in case of the full sequence, which is like this new mode for the AXL Wave. We start with aberration. The interesting thing is that we can see what the patient sees in this upper right corner, so you can always tell the patient, please look at the balloon in the distance, and then we take the pictures, we go through it, we see the initial screen, we can move on to the next one, or we can redo the exam. Those tiny little arrows and information like move back, focus the image, they tell us what to do and how to take the image, because the image are taken usually automatically. You can also do them manually by clicking on the start scan, but preferably it should be done automatically. And then again, with tomography, you see the short screen, and then you can accept this or discard that or add a new scan. This is what the basic view of the Pentacam screen looks like. We have the basic keratometry data, the anterior chamber, the intraocular pressure conversion depending on the thickness of the cornea. We can also enter it manually. Then we have the wide to wide, we have the diameter of the pupil, and these are the basic data. Below we have the available map on this camera. We can change it depending on which one we want. And then we have the three-dimensional model of the cornea. So the front surface of the cornea is red, the back surface is the green, and then of course we have the iris. This is the blue color, and then there is also sometimes a lens, which is the yellow one. We can move this three-dimensional model. We can also add some surfaces, remove the surfaces, and we can also animate this. The largest part of the screen is occupied by the Scheimpflug image, and then on the top left side we have the camera image from the outside, and then we have this tiny little dot shows you where the camera, where the slit of the camera was, so we can move it, whether there are some artifacts. On the right side, you can see the densitometry graph, and you can change the position of the line, and then you see how it corresponds, the very spot, the very section of the cornea, how it corresponds to the densitometry on the right side. Now we are going to go through the maps. Let's start with the one screen, one map, which in my opinion is the most useful in such a quick screening. Yet I've never seen anybody who actually uses this map. This is the fast screening report. And here we have all the information like the ACD, like the angles, like the average pachymetry, like the average pachymetry at the apex, like the minimum pachymetry, like the elevation, like the densitometry volume of the chamber. This black line, this is the patient's result, and it's standardized in relation to the normative group, both in this diagram and in graph. And at the top, we have the buttons for specific map. Let's start with the refraction map. Here we have 4 maps. We have the curvature, we have the corneal thickness elevation map in front and in the back surface. When it comes to metrics and the numerical parameters, here again we have more information than on the basic screening. So we have also information regarding the lens thickness. We also have more information when it comes to pachymetry, also ACD depth and cornea volume. The next element are the large color maps. When it comes to numerical parameters, here not much is changed compared to the previous one, to the refraction map. It is more or less the same, but we can see list of maps to choose from. One, we start with the corneal pachymetry, then we can check where the top of the cornea is, determine the thinnest place, determine the center of the pupil, and just you can see the markers that are on the map, because you can add those markers, which are those little circle or square or a star. You can also see a pachymetry of a particular place within the cornea, so you can click left, click on the mouse, and then you see on the lower side where is this and what's the value. Next are the tangential maps, and we can see the meridional, or we can see the numerical maps. We can see the axial maps, and again the axial sagittal curvature from the axial map. When it comes to the central part of the cornea, it's better to use the axial maps. When it comes to periphery, we would rather use the tangential maps. We also have the axial maps of the anterior and the posterior curvature. We also have total anterior posterior axial maps and also elevation maps. And when it comes to elevation maps, there are plenty of ways we can modify them depending on our need for them. So we can fit the sphere to the ellipsoid, to the toric sphere, or to the best fit sphere, and we can also change the steps depending on what we want. This thing can be done for the anterior and front or posterior surface of the cornea as well, but naturally we can also use the auto function, and then it will be adjusted to the best fit sphere. You see all these measurements here are in micrometers, so that's the unit that's used on this map. Then we have the true net power. That's the determination of the power of our entire cornea. The next map is the keratometric power deviation. It is the influence of the back surface on the power of the cornea. The next, we will see the depth of the chamber. Can of course be switched in general, but it's already in the settings, whether we want to show from the endothelium or the epithelium, right? The default is the endothelium. Next, we have the refractive power of the front, and of course we have the relative pachymetry, which is basically what is the thickness of the cornea in certain place in relation to the normative data. We also have the equivalent of keratometric reading. This is the map that was created by Jack Holladay, a map that corresponds to the Holladay report. I will talk about this later. But here we mean this is to determine the equivalent of keratometry in a situation when we have a complicated cornea, for example, after refraction or after radial keratectomy or corneal ectasia. Then, of course, we will have a problem with counting the intraocular lens. In this case of the equivalent there can help us for this. Next, we have the total corneal refractive power, and then we have the corneal densitometry, average and maximum. Now we are going to move by clicking on different maps from the main menu. Maybe you have noticed that with these numerical values, in the lower corners of the frames, there is a yellow triangle. If we move the mouse over it, we will automatically see the explanation. And this is something that's amazing and really remarkable for this machine, because in fact, here there are a whole bunch of the functions and parameters. Instead of looking into the manual, you can just move and see what's the function or parameter about. The whole interface is available in many languages, also in Polish, so there's a full graphic design in Polish. I usually use English and by default, and we are going to use English. So let's move on to the analysis of Belin-Ambrosio. Belin-Ambrosio, this is the map where you have the prediction of the probability of keratoconus or any other ectasia. And here we have the whole analysis. On the left side, we see these 6 maps. So at the very top, we have the map of the anterior elevation, and on the right, we have the posterior surface of the cornea. Below, we have the elevation map already with the algorithm, Belin-Ambrosio. What this algorithm does is basically it cuts out the area. Depending on the software version, it could be 3 millimeters in the center, or in that case 3.5 millimeters, in which there is the thinnest spot of the cornea. The solid line defines as 3.5 millimeters in diameter from the thinnest place of the whole cornea. And now, why do something like that? It turns out that in early keratoconus, these changes can be subtle, that the place with the thinnest cornea and this area can simply falsify the whole results. At the very bottom, we have the 2 maps. This is the difference between what we have in this patient and the reference cornea. And of course, these differences are different depending on whether it's the back surface or the front surface. And for example, for the back surface, from 12 to 16 micrometers, it will be marked in yellow, meaning that this is like slightly warning, slightly suspicious. And then if it's more than 16, it's going to be red, and this is highly suspicious. We still have 2 graphs. One is corneal thickness spatial profile in relation to the norm, and these dashed lines are the limits of the norm, whereas the red solid line is the result of the patient's cornea. So we see that here it's more or less within the normal. Below we have the percentage increase in corneal thickness depending on the cross section, and here it's also relatively normal. We also have the progression index, and of course it is same principle applies. So it can be yellow, it can be red, it can be also black, right, in case of normal. This is the progression index depending on the decrease in thickness over the profile. We also have the pachymetry values, the lower, the thinnest, and where it is located. And then we have the keratometric values that we know from the previous maps. On the right corner, we have the pachymetry map together with the scale. Okay, so the last fast screening map is the refractive map. This is basically the map that shows us if the patient is a good candidate for a refractive procedure or not. So what do we have? We have the, again, corneal thickness spatial profile. We have the asphericity front of major meridians. Then we have the pupillary center, thinnest location, and location of the K-marks. We have the Placido indices like the THC, like CKI, But again, if we have a suspicion that the patient has a keratoconus, we should rather look at the Belin-Ambrosio. Below, we have the color maps of the axial curvature, corneal thickness, and the elevation. And we also have just regular K1, K2, Km, ACD depth, angle, and astigmatism and axis. Once again, we are back at the fast screening report. I encourage you to use this, and for most patients you just need those maps, right? And then you're done. You don't need to look at most of the features in Pentacam. Fast screening plus those maps is enough. And now let's quickly look at the Belin ABCD keratoconus staging. So here we have two maps, the axial front and axial back. Below we have the Belin ABCD keratoconus staging. This is very useful staging system. It basically takes into account four things: the ARC, the posterior radial curvature, then the thinness pachymetry, and the best corrected visual acuity. Naturally, you need to add the BCVA here as basically Snellen equivalent. Like here, this patient sees 20/40. So then in the end, we will have A4, B4, C4, and D1. And then below we have the indices that I showed you previously, but I just didn't talk much about them. So here we have the ISV, that is the measure of the standard deviation of individual sagittal radii from mean curvature. Then we have the index of vertical asymmetry, that's the EVA. This is the mean difference between superior and inferior corneal curvature and the level of curvature symmetry with respect to the horizontal meridian as the axis of reflection. Then we have the KI, which is the keratoconus index. This is the ratio between mean radius value in the upper half and the lower half of the cornea. Then we have the central keratoconus index, CKI. This is the ratio between mean radius of curvature in periphery. Then we have the index of height decentration, EHD. This is the measurement of the vertical decentration of elevation. And then we have the R-min, which is the smallest radius of sagittal corneal curvature. But KC staging is not the last word that Pentacam has to say about keratoconus, because naturally it also has progression. So here we have the progression. This patient has all the scans since 2013, and the results are grouped according to ABCD classification that I explained a bit earlier. So we have all the data from this on the time period next to each other, and then we have the flags. The red flag, 80% keratoconus, and the 95% keratoconus chances. We can have both eyes next to each other. We can have one eye. We can also have the absolute scale, or we can have the scale aligned at baseline. This patient had keratoconus and also had cross-linking. We can add the date of cross-linking, and this would be automatically put on this display. So here we have the date, and then we can see that the procedure was successful, that the ARC, PRC, and also thinness location got significantly better for that patient. One of the unique features of Pentacam is the corneal densitometry. This is more or less the blockage of light when it passes through cornea. And here we have two maps. One is the colored map with numerical values. This is the colored densitometry. And then you have this grayish map in the left lower corner, and this is basically the en face of the Scheimpflug image. So all the opacities are going to be whitish, plus you also have the numerical values. Now above that you have this red line, and this red line is basically the cutoff from the cornea. So you can move the playhead like we are moving right now, and it's changing the red line, and then you have the value, and this value is the distance between the corneal epithelium and this red line, and what's the corneal densitometry is below that. But you can also have like the second line, and this would be just the slab of the cornea that you want to image using the numerical values of the corneal densitometry. The corneal densitometry is most useful when you have like corneal scars and you want to see how they develop, because Scheimpflug naturally doesn't have the resolution of OCT. Corneal densitometry is a substitute of OCT resolution. So when do we use this? Like here in this patient who has significant scarring after cross-linking and some opacities. Naturally, the benefit of that approach is that you have numerical values. So it's not just, oh, it's more hyperreflective or it's less hyperreflective, but you can compare and monitor the patient during treatment. Now let's talk about the Holladay report. So let's imagine that we have a normal, healthy cornea. If you want to calculate the total corneal power, the easiest way is to sum the positive refractive power of the anterior surface and the negative power of the posterior surface. In healthy corneas, there is this stable proportion, and it's more or less 82% power of the anterior surface. And the older IOL formulas were made like this. So you only made the keratometry of the anterior and then just multiplied it by 0.8. But what happens if you have a keratoconic cornea or a patient who has undergone a refractive surgery? Then those old IOL formulas are not going to provide you with reliable result. So this is why you need Holladay report. So what do we take into consideration here? Firstly, anterior and posterior surface, pachymetry, relative pachymetry, and this all together within the 4.5 millimeters, because more or less this is the size of the pupil within the mesopic condition. Here we can see a table in which this size of the pupil can be changed. So it could be from 2, it could be 4, it could be 5, it could be 7. Naturally, within the Pentacam, we can check the size of the pupil under different conditions using Pentacam. And we can, based on the values that we see that the patient's pupil is, we can take the ERK value for the K1, K2, and then input this value into the IOL formula. Let me show you now the cataract pre-op. This is the screen that you can use in cases if you have a potential patient who is a candidate for a premium IOL. So what do we have here? We have the Zernicke analysis, Z40 and the HOA. We have the kappa and alpha angle. We have the Belin-Ambrosio metrics. We also have axial sagital or total corneal refractive power and the corneal thickness. In this case, the question is naturally, should we implant the premium IOL? In this case, naturally, nope, because this is the keratoconic IOL. Naturally, we also have the pachymetry at vertex, the thinnest, and also difference between them. Pentacam also offers the aberration of the cornea, so we can have the wavefront front cornea aberration, wavefront posterior aberration of the cornea, and then the total corneal aberrations within this. And this can be displayed as a list, as a pyramid, or as normalized. And the normalized is pretty interesting because you can see the all the names of the aberrations within the range for the normal group. We can also have this animation, so we can add the LOAS, we can have the HOAS, we can add or subtract, and you see that there is difference in this 3D model of the corneal wavefront. In case if you're lucky enough to have the latest Pentacam, the wavefront, you can have the total aberrations as well. And here you can change between the higher orders, lower orders, and the display can be done into bars, into pyramid, into vectors, and then we have the color map, we have also the infrared image, and we have on the lower left, we have the Hartmann
shock sensor image. The device has also the IOL calculator. In case of more advanced versions, our also has the AXL, so basically the axial length will be placed into the formulas automatically. Or you can use it as a calculator and put the values from other machines as well. So there is a huge database of lenses. So you have spherical, aspherical, toric, multifocal. But what is more interesting are the formulas. So you have the standard like SRK, Haggis, Hoffer, Holladay, Barrett. But also you have some specific post-refractive surgery IOL formulas. Or you also have the toric IOL formulas that takes into account total corneal refractive power, which is special for Pentacam. And you also have toric after refractive surgery, that kind of calculator within Pentacam. Next, we have the intracorneal rings. We don't use them because we have some bad experience with them, but we can have the simulation between the manual dissection technique or the femtosecond laser, and you then have all the minimal thickness and thickness of the cornea that's necessary. It's more or less clear, and because I don't use this, I'm not going to dwell on that. Naturally, a more interesting thing is the phakic IOL calculator. Start by choosing an phakic IOL from the database. Then we have all the information that we want. We have the endothelium clearance, we have the iris clearance, and this is displayed on those two colored maps based on the shape and size of the lens. Again, you see the Scheimpflug image with two red lines. This is the distance that you need. You can move it back and forth. You can also change the position of the slit camera and then see where it's going to be based on this. An interesting feature is the aging prediction. So basically during a lifetime, the more ages we have, the smaller the AC is going to be. So we have to also take into account this factor, and we can see the simulation of aging. In the end, I just want to show you the comparison option. So I showed you the comparison when it comes to keratoconus in cases of the Belin-Ambrosio staging, ABCD staging. Here we can see the difference between the maps, and there is naturally one map minus second map, and then the third map is going to be difference between A and B, and then we can have whatever we want, whichever map we would like to have. What else? We have the, let's say, compromise between just the maps and the values, or we can have maps or the values. And naturally, we don't have to have the former versus the latter visit if we wish, or the opposite, or first and fourth visit, or fourth minus first visit, as we want. Another thing that we can compare is the comparison of the Scheimpflug images. This is extremely useful in cases of monitoring of the corneal opacities, let's say after keratoconus or after refractive surgery during the diffuse lamellar keratitis. We can have these two images superimposed on each other, or they can be next to each other, which I find somehow harder. And then the last map I would like to show you, this is the latest upgrade that's only available for the most advanced Pentacam, because here you have the refraction, right? That's calculated by this machine. So the interesting thing is that you can have the refraction under the scotopic, under the photopic condition. Naturally, you can imagine that with the enlargement of the pupil and the change in the ACD, it's going to change, right? So you also have to consider this to calculation of the refractive surgery or to the clear lens exchange. What else do we have? We have simulated keratometry. We have the free maps we can change. We have the simulation of the patient's view. We have also the corneal properties like the Belin-Ambrosio. Then we have the corneal thickness. We have the aberrations, HOAS and coma, and then we have also the axial length. And the last thing that we can see is the retro illumination. Here we have the infrared image as a default, but we can also have the axial map with the axial position. Then we also can add the axis. After the toric IOL implantation, we can see where is the axis located of the toric lens thanks to these tiny drops on the toric lens and the retroillumination that this machine has. And we can simulate the adjustment of the IOL position if it is needed. In the end, we have the contact lenses position. I don't do it. I have no idea about contact lenses except for the bandage contact lens. But there is certainly this option, and the machine will suggest the best contact lens for that patient. Okay, this is the review. And I would like to start by saying that Pentacam is like a lingua franca for all the refractive surgeons, right? Everybody understands this. This is the gold standard. And if you just PubMed Pentacam, there's more than 2,000 results. If you just PubMed Pentacam reproducibility, there's more than 400 papers just assessing the reproducibility. On YouTube, you can find hours of videos on different maps like Belin-Ambrosio enhanced ectasia, Holladay report, and so on. Plenty of resources. Most of the refractive surgery books are based on Pentacam. So that's certainly easy. Also, if you want to refer a patient, you just send them Pentacam image and everybody knows. If I'm getting, let's say, anterior map, I'm like, it takes me, few minutes to understand which map is this and what colors are. And when I get Pentacam, everything is obvious. So yes, this is the gold standard. Pentacam has plenty of competitors. On the one hand, there are Scheimpflug cameras like Galilei with Placido built in. Sometimes you have Scheimpflug and OCT, and also devices like Cassia or Antirion. The question is, which one is better? For me, Pentacam is the last resort. This is the Supreme Court for detecting keratoconus. If I don't find a keratoconus in Pentacam on enhanced ectasia or Belin ABCD, that means the patient doesn't have it, period. I showed you previously that if you just click on the map, there are references to literature that show this. Another thing is you have the reference range and the normative base, which doesn't come from most of the other machines. So this is certainly a plus. You are buying a machine that's tested, that has been fully examined and gives reproducible results. That's a very important point for somebody who wants to do the refractive surgery. Secondly, you have the axial length and you have the wavefront aberrometry, plus you have also manifest refraction. So more or less, this is like the one and only machine that you need for cataract and refractive surgery, right? If you think, for instance, about the aberrations, right now you have total and you also have corneal, but front and posterior surface of the cornea, which is, for instance, not present with eye trace, right? Which claims to be like the best aberrations with ray tracing. I made a video on eye trace. I don't think this is a bad device. We have it, we use it, and more or less I'm happy with that. The machine is very nice for showing the maps to the patient, but it lacks the pachymetry, it doesn't have the axial length, it doesn't have the posterior elevation, so you can see this is only an addition to the Pentacam or any other machine that makes those measurements that I mentioned. I'm talking about eye trace because I've actually heard two refractive surgeons who told me like eye trace is the only machine you need for refractive, and 100% I don't agree with that. I think that a machine like Pentacam AXL Wave is the only machine you need, period. The question you might ask is, why did we buy an axial length? Don't we have a biometry? Of course, we have IOL 700, we have, I think, 3 IOL 500, we also have Galilei with axial length, so we have plenty of machines that can actually calculate, but because we use this for refractive purposes, And many patients who have, let's say, weird corneas are coming to our clinic. We always want to have that kind of machine that is able to calculate the corneal metrics under every circumstance, right? Because IOL Master 700 will not calculate you some very, very ectatic corneas. And we have those patients for IOL implantation. And using this machine, together with the axial length, that means we can calculate every patient who comes to our clinic, no matter how weird the cornea is. Another huge advantage is that this machine is 100% customizable. So you can change the colors, you can change the scales, you can change which maps do you want, which lenses do you want, as which biometry calculators you want to use. So it's also very user-friendly, and also you can customize this as well. So what are the downsides of Pentacam? Firstly, it requires dark room. Secondly, it's not that easy to operate the machine at the beginning, and it will take some time and experience in order to capture valid images. The third problem is that it takes some time to get image. The acquisition speed is not as fast as with the OCT devices. And speaking of which, this is the biggest downside of this machine. The lack of high resolution images like you have on the OCT machines makes it very difficult or even impossible to properly diagnose corneal dystrophies, visualize the angle, or detect a DMEG or DSEG graft detachments. Moreover, because of the low resolution, you don't have the epithelial maps. The machine also doesn't have Placido, so there is no way to measure and see the tear film. But on the other side, you don't need Placido with the wave because you have Hall refraction. And also the downside of the Placido is that you need to blur the patient. You need to put some strong light. And you cannot do that before you measure aberrations. So this is not really an issue here. The machine is also not cheap. It's the same price as a good OCT. It's the same price in Poland as Antirion, for instance. But on the other side, you get here a normative database, which is quite rare for the anterior segment machines. And also all those maps, all these are validated, have been tested, and this is probably the most accurate keratoconus screening tool. So if you're serious about anterior segment, if you're serious about refractive, yes, you should buy this machine.
Thank you very much for watching my review. I hope you've enjoyed. Please subscribe to my channel, and goodbye.